Part 4 of substitution, we're going to try and tackle some more work on fractions. Because there are lots of different kinds of tricky situations we need to solve. So, let's start with a straightforward expression, like 3x. And I'm going to make x equal to 1/4. So, what does 3x mean? Because our first line is always writing out what the expression means. That's 3 times x. So 3 times x, when we substitute in, becomes 3 times 1/4. Now, there are two different ways of seeing this substitution. One is to go 3 lots of 1/4 is 3/4. And some of you will see it straight away. The other way to see it is to write 3 as 3/1. And then use your rules for multiplying fractions. So you multiply the numerators and multiply the denominators because there's no cross cancelling. Now in this situation, multiplying the fractions and checking for cross cancelling is okay. But this works very nicely. 3 lots of 1/4. So there's 1/4, there's 1/4, and there's 1/4. So it's just 3/4. It's up to you which route you take, and maybe you'll vary it depending on the situation. But in this case, I would suggest a common sense visualization. So, let's now look at a slightly trickier one and build our way up. (10 minus 2x). In this case, x is going to be 2/7. So the first thing we do is write it out longhand. So it's still 10 subtract 2 times x. Now we substitute. Now we're going to think about which method to use. I'm going to do both for you. Let's go common sense first, the kind of simple approach. Keep that there because of BidMath says do this. 2 lots of 2/7. So I've got 2/7 and another 2/7. So I've got 4/7. Okay. The alternative was to make the 2 into 2/1. Then there's no cross cancelling, so it's 4/7. Now, this sum isn't an easy one to do. If you think back to our adding and subtracting fractions videos, you might remember some clues. We're going to have to take one of our whole 10 and slice it up into sevenths in order to take away 4/7. So one of these gets sliced up, which means I have 9 whole ones remaining. Now the one that gets sliced up into sevenths originally gives me 7/7. So let's write that down like that for now. When I take away my 4/7 from that one that's chopped up, I've got 3/7 remaining. If it helps here, you can draw a diagram. I wouldn't draw 10 whole bars, just draw the one you're going to chop up and remind yourself that the 9 whole ones remain, one gets chopped into sevenths, and then you take 4 of those away, leaving you the 3. Hopefully so far so good. Let's continue on. It had to happen at some point. We've now got indices and fractions. I'm going to make x equal to 2/5. I'm going to make y equal to 1/4. So no negatives yet. First stage, write it out. Second stage, substitute the values. By now your setting out is really clear and consistent. Multiplication will come before the subtraction. 3 lots of 2/5. So that's 2/5 and 2/5 and 2/5, which is 6/5. One quarter multiplied by 1/4. Well, 1 times 1 is 1. 4 times 4 is 16. Once we'd gone from here to here, we'd done our substitution. It became just a fractions question. So, a reminder, when we are subtracting fractions, we want to have the denominator the same, because we want to have the size of each piece the same. So we're going to think about times tables and where these meet. And I'm going to write out the 16 times tables because I know the 5 times tables end in 0 or 5. Now, if it's easier, add 10, then add 6. 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 Take your time with those to make sure it's correct. And bingo, 80. 1, 2, 3, 4, 5. So both parts here are multiplied by 5. This is times by 16. So both parts are multiplied by 16. Practicing your number skills and getting them really well developed is crucial for this topic. So we've looked at fractions, we've looked at indices, we've dealt with some tricky calculations there. What we'll do in the next video is we're going to use fractions, indices and negative numbers all together.